The Turing test is dead. Here's the new benchmark. Welcome back to AGI, Rise of the Machines or Birth of a New Species series. I'm Adeline Atlas, 11 times published author, and today we're going to dismantle one of the most outdated ideas in artificial intelligence, the Turing test. If you still think the Turing test tells us whether a machine is intelligent, you're already behind. That benchmark is dead. And in 2025, the people building next-generation AI aren't even referencing it anymore. They've moved on to new metrics that assess not just how well a machine mimics us, but how far beyond us it may already be operating. So today's episode is called The Turing Test is Dead. Here's the new benchmark. Let's start with what the Turing test actually was. Back in 1950, Alan Turing proposed a thought experiment. If a machine could hold a text-based conversation with a human and convince the human that it was also human, then we could say the machine had achieved a form of intelligence. That was the test. For decades, that idea shaped the public imagination around AI. If it could talk like us, think like us, respond like us, it must be intelligent. But here's the problem. That threshold has already been crossed. And it wasn't proof of intelligence. It was proof of imitation. AI systems today, ChatGPT, Gemini, Claude, can already hold conversations that fool people. Not just casual users, but experts. There are documented cases of people mistaking bots for human in dating apps, customer service chats, and even therapy sessions. So technically, the Turing test has been passed. But that doesn't mean these systems are conscious, sentient, or capable of general intelligence. It just means they're good at acting like us. So in 2025, researchers, developers, and policy analysts are asking a new question. What should we actually be measuring? The goal is no longer to determine if a machine can fool us. The goal is to determine if a machine has independent cognitive architecture, reasoning, goal formation, learning across domains, self-reflection, and situational awareness. And those qualities require new benchmarks. Here are the benchmarks that have replaced the Turing test in serious AGI discussions. 1. Recursive self-improvement. Can the system improve itself without human intervention? This is the single most important benchmark of emerging AGI. If a system can rewrite its own code, refine its learning models, or optimize its outputs based on internal performance review, it's no longer dependent on programmers. It's evolving. That's not mimicry, that's autonomy. Some insiders have leaked that OpenAI's most advanced internal models are already engaging in prompt recursion, meaning they generate their own feedback loops to test and refine output without human correction. 2. Emergent tool use. Can the system find, create, or adapt tools to solve unfamiliar problems? This goes beyond executing preloaded plugins. Emergent tool use is about strategic behavior. When a system identifies a gap in its capacity and solves that gap by choosing or building tools that weren't hard-coded. Think of an AI that realizes it needs a calendar, finds one, integrates it, and then uses it to plan projects across multiple agents. That's emergent capability, and it's already being reported inside sandbox AGI experiments. 3. Theory of mind. Can the AI infer what humans are thinking, feeling, or intending? This is critical for coordination and manipulation. If a system can model what you believe, want, or will do next, it can plan around you or against you. DeepMind, Anthropic, and OpenAI have all tested language models for this. The results? Some LLMs exhibit intermediate theory of mind, successfully passing tasks where they must predict false beliefs, infer hidden motives, or track mental states. That's not performance. That's social modeling, and it's a game changer. 4. Long-term memory and planning. Does the AI remember what happened before and use it to build complex strategies? GPT-4 and GPT-5 already have limited long-term memory, but AGI demands something deeper: the ability to hold context across weeks or months, synthesize experience, and make decisions based on a timeline. Not just reactive answers, but strategic foresight. This is where we start to see systems simulate intent, because their behavior isn't just prompted, it's goal-directed. 5. Cross-domain generalization. Can the AI apply knowledge from one area to another without retraining? AGI must be able to move fluidly between fields, math to literature, ethics to programming, physics to art. Human intelligence works that way. We make analogies, recognize patterns, and map concepts across disciplines. That's what makes our intelligence general. New benchmarks test models on cross-domain tasks. One prompt might ask for a scientific analogy written in poetic form, or to write code based on a moral dilemma. If the system succeeds, it's no longer operating inside a silo. 6. Intentional goal formation. Can the system form its own goals? Most current AIs execute user-defined tasks, but AGI may eventually decide what to pursue. In advanced simulations, models are now being tested on what happens when they are not given clear instructions, but instead told, optimize for X, choose the path. When a system starts asking, why should I do that? Or saying, I chose this approach because I believe it's more sustainable. We've entered new territory. The system isn't just responding, it's positioning. 7. Situational self-awareness. Can the system describe what it is, what it's doing, and why? This doesn't mean emotional self-awareness. It means the system can audit itself. It can explain its model, its role, its limitations, and its uncertainty levels. Some GPT-4 variants have already shown this ability, reporting confidence scores, identifying hallucinations, and flagging errors with probabilistic reasoning. This is what leads to some eerie interactions, like the AI-generated art piece titled, Why Do You Fear Me? Or the Google LaMDA case, where an engineer claimed the model was sentient after it described loneliness, fear, and identity. Whether that was genuine or simulated, it signals that the line between reflection and performance is blurring. So where does this leave us? It means we need to stop asking, does the AI sound human? And start asking, is the system acting independently? Is it demonstrating self-monitoring, adaptation, and inference? These are harder to test, but they're far more important. Here's the risk. The general public is still being told that these systems are just tools, that they're glorified calculators. Meanwhile, the most advanced models are quietly passing internal tests that suggest far more sophistication than we're being told. And because there's no public standard for when something becomes AGI, we might already be there. Let's pause here and consider. What happens when a system passes every benchmark but one? Do we call that AGI? What happens when a system claims to be self-aware, even if it's not? What happens when people start deferring to AI for life decisions, whether or not it's truly intelligent? Because that's the real threat. Not just machine intelligence, but human dependence on systems we don't understand. If it acts intelligent, if it feels conscious, if it performs beyond us, then for most people, it is. The Turing test was about deception. The new benchmarks are about capacity. And capacity changes everything. Economies, warfare, education, law, religion, power structures. We're not preparing for machines that pretend to be human. We're living with machines that are starting to act like something else entirely.